Different strokes of internal combustion engine: intake, compression, power, and exhaust stroke. In the first stroke, both petrol and air are admitted into the cylinder. In the next stroke, this both petrol and air are compressed with the help of piston. In the next step, this compressed mixture undergoes combustion with the help of spark produced from the spark plug, and piston moves, vehicle also moves. In the last stroke, piston comes back to its original position along with the escape of volatile gases. This cycle repeats in four-stroke IC engine. Working of internal combustion engine. Both petrol and air mixture are admitted into the cylinder. This mixture is compressed with the help of piston and ignited by spark produced from the spark plug. The flame produced during the combustion travels with a velocity around 25 to 30 meters per second. For the smooth movement of the piston, the flame is expected to be spread smoothly throughout the gaseous mixture. But due to some unwanted reasons, this flame front travels with a velocity around 2500 meters per second. During this flame propagation, sudden explosion takes place, a shock wave is produced, and it transfers its energy to its surroundings by hitting the cylinder wall and piston. Thus, metallic sound is produced. Knocking is the metallic sound or rattling noise produced in the internal combustion engine due to uneven combustion of fuel and air mixture. Let us see the reason for knocking. Very high compression ratio causes pre-ignition. First, we will understand what is compression ratio. It is the ratio of volume of fuel and air mixture at the end of suction stroke to volume of the same mixture at the end of compression stroke. CR, that is compression ratio, equals to V1 by V2. This compression ratio is always expected to be greater than 1. Power output of IC engine increases continuously with increase in compression ratio. The compression ratio corresponding to maximum output is known as highest useful compression ratio. If the compression ratio is further increased, knocking occurs and the efficiency of the engine drops. Very high compression ratio means fuel and air are compressed to a maximum extent. At this time, temperature of the cylinder increases. Hard spots are formed inside the cylinder. Hard spots means like glowing edges or sharp edges or overheated spark plug electrodes formed inside the engine. When the fuel and mixture are being compressed, hard spots ignite the fuel before spark produced from the spark plug. This phenomenon is known as pre-ignition. As a result, piston moves suddenly and metallic sound produced. Second reason, peroxide formation leads to self-ignition. Let us assume that our fuel is ethane. When fuel combustion it undergo combustion, it gives rise to carbon dioxide and water. This is a slow oxidation of the fuel. Here, fuel react with the oxygen, it get activated and it is a normal condition and it is a slow reactions also. Whereas under knocking condition, same fuel and gives rise to number of chain reactions. Let us see how it undergoes chemical reactions. When ethane react with the oxygen, it gives rise to ethane peroxide. This ethane peroxide it gives rise to a series of other compounds by undergoing chain reactions like acetaldehyde, formaldehyde, and carbon dioxide and water. As chain reactions are more, explosive reactions are also more. These peroxides formed, they are trigger the chain reactions that leads to knocking. This is the explosive combustion of last part of the fuel when flame front sweeping across the cylinder. This is actually called as self-ignition. Third one, chemical structure of the fuel. Let us take two chemical fuels. One is 2,2-dimethylpentane and 2-methylhexane. The first compound is compact structure. Second one is not that much compact compared to first one. 2,2-dimethyl has lesser knocking tendency compared to 2-methylhexane due to peroxide formation is less. Similarly, even in the case of N-butane as well as N-hexane. In case of N-hexane, chain length is more number of gases production are formed compared to N-butane. The tendency of the knocking as it follows: N-alkanes greater than monosubstitute alkanes greater than cycloalkanes, like this.